Alright, so now we're going to take apart the sub-assemblies just to give an inspection of what's going on with the unit. I forget this is a 2012. So the design on this unit, the design changed on 6L80s from 2007 to 2010, again in 2012. And I want to say some changes were made in like 14 or 15. Overall, it's the same unit. Some differences in them, not much. So I'm gonna go ahead and take this carrier assembly. I don't know what I was thinking about earlier. I need to take the snap ring off of it. Let's get the planet out of it. There's a bearing goes here. Where is it at? Where is it at? So let's go ahead and get that done. Let's start with that. Start with the easy stuff, right? So there's a snap ring in here. You can see it. It's beefy. I just want to raise it up out of its groove just to get it over the shoulder. You'll notice I have my hand right here just in case the snap ring wants to jump this way while I'm moving it. I'm gonna pick here, kind of go around the edge of it in case it wants to jump. Should get it out now. Should be good to come out now. So there's that. Goes there. I don't recall if that's there on the 15 and up. I'll double check. I just did one. We can take this out now. If it allows us to take it out, let's flip it over. When in doubt, flip it over. So we got the fluid dam here. There's a 2-piece. I want to say it might have been 13 when they changed that design to a 1-piece, a unit design, where the snap ring there's no snap ring. It's 1 piece. It's all 1 piece. Check the rings. There's another one, a snap ring here. It's just separate. Just check where the ring lands are to make sure there's no any type of scoring, like severe scoring, chipping, something that may have gotten caught in the gear train and caused it to chip off one of the teeth. Expect that later. I need to get another couple rags here. Have to keep some clean rags. All these components are going to be cleaned off. Like, when I mean clean off, I mean clean. Like, we're literally back to shiny new. This is a fluid dam here. So let's get this ring set off. Shit, come back. Comes off like that. That way we can inspect it. Again, we're checking the teeth. Check these teeth here. They don't have lights on. Check these teeth here for any type of chipping. Not very a common thing. Still check it anyways. We're gonna check the pinion gears here. Same deal to make sure there's no chipping and scoring on them. If there is, it will have to be replaced. This is a very high dollar piece component here. Make sure everything's turning and spinning like it should. Sometime if you have some, if you have like lateral play in them, then it has to, they're going bad and have to be replaced. Sounds like I heard a bearing. There it is. I was looking for it. What was I looking for? Right here. It was right there. Let's put that over there. Snap ring go with it. So they'll stay together. This is where the oil is starting to come. Gotta keep it clean. This is a very dirty unit. Next, we're gonna take apart the 2.6 center support bearing in it. Put the bearing with it. Goes there. ATSG service manual is a must. I've done so many of these units. And I still look at the ATSG service manual when I assemble them. I mean, I know how they go together, I know how they come apart, but it's just, you know, good practice. This is a low reverse sprag here, and it ain't spragging. Well, let me take the clutches out of it first. I can kind of tell just by looking down in here that they're not that bad, really. So I doubt we're gonna have any issues, but I'll still open them up. That kind of tells a tale, pretty much kind of tells the story of what's going on with the unit. We got burnt up clutches, no forward motion. You know, we might have a lubrication problem, a pump problem. All I did was just flipped it over just to get an idea what the clutches look like. This is the wavy here, so they go in like that, sit down like this. You got the apply plate on the top. Got a friction there, steel there. Looks worn. It looks used. They're not burnt. They stink. If you could smell them, they have a char kind of smell to them. They're not burnt up as. They actually don't look as bad as I thought they would because I can smell it. I don't really see many hot spots. Anything that's indicative of overheating. Obviously, the oil color, the fluid color would tell me that it did definitely overheat, but I mean, I've seen worse. I mean, there's always a worse case scenario. The wavy looks fine. When I say wavy, you'll notice that it's not a flat circle. If you look at it that way, it kind of has this going on to it. They don't look bad. The steels and frictions have to be replaced on an overhaul. If you're doing a repair, which is kind of a cost-effective option, you don't have to replace the steels. They're not always a requirement. You can refurbish them. Just depends on you how much money you want to spend. Let's check the low reverse sprag and make sure it's spragging. Before I took it out, I was trying to spin it, not even realizing that they were locked in place. But so the low reverse sprag, it freewheels in one direction and it should lock in the other direction. Obviously, you don't want the vehicle to be stuck free spinning in one direction, so it'll spin this way, but it won't spin that way. If it does, you have a problem. Sprag has to be replaced. You can open this and service it and replace the actual the sprag, the lands. They call them elements. Forget how many pieces there are, how many elements there is to it. There's a piston down in there that has to be replaced in the overall kit. The thing with the pistons, I don't check pistons because they have to be replaced. There's really no surefire way of checking a piston. So I mean, you know, just replace it. They're not that expensive. They come in the kit. You can buy an entire set of pistons for this unit for like $120. Now, you know, that's small change compared to the type of damage that you can incur and the time you can incur, the time loss you can incur not changing them. You know what I'm saying? So I just change them. I don't even worry about, you know, I'm inspecting the clutches and the frictions, like I said, because I want to get an idea of what was going on with the unit, what failed, you know, obviously what has to be replaced. This is going to be a complete overhaul, so it doesn't really matter, but I still inspect them. But the pistons, they're just a must. There's no sense of looking at them because they're going to be replaced anyways. And again, there's no way to really look at them and tell like, oh, this one's burnt up or this dude's still good. Rubber's rubber. You know, when it's hot, it gets soft. When it's cold, it's stiff. It's going to apply or it's not going to apply. Whatever. 2.6 right here. Apply plate on top. Oh, we've got some hot spots. There we go. So when I was talking about the hot spots and indications of overheating, this is what I meant. So you see I can't wipe this off. When steel gets hot, or any metal really, to be honest with you, it'll create these markings, heat marks, tempering marks. That's what that is. These are hot spots. These cuts was binding up, overheating, lack of lubrication there on every last one of them. So all of these steels are going to have to be replaced. Wavy looks fine. Wavy still waving at me. But these steels are shot. They're toast. Friction's held up pretty good. Kinda didn't expect them to be I thought they would be a little flatter with the hot spots, but you see these ridges on them. I thought they would be a little flatter than that, a little more charred. But this is more than likely due to poor lubrication. So I think we're going to have a pump. I think the failure point was going to be the pump or the torque converter, one of the two. There's a Belleville spring here. Again, there's a piston down there. Has to be replaced. Don't even matter. We'll take it out. There's a snap ring here. Belleville spring comes out and the piston comes out. That's all it is. There's nothing to expect on this element of this sub-assembly, because the pistons are going to be replaced regardless in the piston kit. So that is a must. Put that there. This is going to get a whole new set of frictions and steels. Steels are a must, a requirement. The other ones are going to get them not because of necessity, but because it's an overhaul. It's going to be a complete overhaul. This is not a repair. So if there was a repair only, then you could just replace those frictions, refurbish the steels, with some Scotch-Brite or something like that, and send them on their way. This is the dampener. I'm not going to open a dampener because there's nothing really to expect on it. It's another replacement item. Just you have to replace it. There's nothing on it that would be indicative of it being worn down outside of like middle to middle scarring. But it's the type of item that it's one part. Just replace it. Snap ring comes out. Dampeners inside, and replace it. I'm just cleaning it off. It's got some heat going on that. Nothing in there. There's nothing in there. There's a bearing on the back. 456 is going to be next, and 456 is pretty toast. What you look at it. What you just look at it. Look at this bearing surface. This bearing does not come apart. It's a land. It's not a bearing, but that land doesn't come off. The bearing sits on top of it. It doesn't look bad. But I'm going to open this 456 because it has clearly been charred, like really something tough. Snap ring, obviously. Take it out. Come around the side. Snap ring pops out. I'm going to replace this snap ring. Dime a dozen stuff. I'm going to replace it because I don't like the way it looks. Not to say that its performance is being hindered by the heat. I mean, heat does wear metal. It's not going to get soft or anything like that, but we're talking something that costs a few bucks. Just go ahead and replace it. Again, if you're just repairing it, it's not necessarily something you have to do, but in the overhaul, things like that are a part of they're on the replacement list. There is a bearing on the back of here. It should have failed, but sometimes they'll get stuck. The Torrington bearings, replace them. They have kits for them, like $50. They don't have to be replaced unless you know that they're broken. But again, it's an overhaul. Everything doesn't have to be replaced in repairs. There's people have different methods of doing everything. But when you're warrantying a unit, you have to replace the things that kind of that may not last during the lifespan of your warranty. I mean, obviously a replacement, the warranty is a little bit shorter. I'm sorry, a repair, the warranty is a little shorter. So you may not have to replace every single thing, but when you're doing an overhaul and you have quite a big long of a warranty, you want to replace all those components so that you don't have to take it apart 2 and 3 times, for the sake of the warranty. I like to check this to make sure these tabs aren't broken. These tabs, they lay into the back of this gear here. This is the bottom of it. It sits in it like that. If there was any type of violent, thrust, sometimes it'll break. It sits in like that, and it sits down on it like this. But if the tabs break and it starts moving, or it's allowed to move, you can have it move out of place. Then you got metal on metal. Don't want that, obviously. So that washer, there needs to be attention paid to that washer when checking it in this 456 assembly. You can see that purpling down, that bluing. Where this drum has been heated up pretty good. Piston in here, snap ring goes down there. This has to be removed on a press. piston's going to be replaced because I'm just looking at the amount of heat that it has endured. That would warrant, just the heat alone, the color of the oil alone would warrant the pistons being replaced. You know, there's like I said, there's no way to really look at them and tell that rubber's, you know, dying, so to speak, or it's failing, degrading. It's just kind of a knowing. I'm just looking at the inside here. Look at all that build up in there. Looks pretty bad. Take this snap ring out. This has to be compressed down. There's a balance piston inside of it. It's two pistons actually. There's a balance piston right here, or oil dam, what do you want to call it. There's one on the bottom. There's an apply piston. Those got to come out and get replaced. I don't have this set up on the press to do it now. I do have one, but it's not. I'm not gonna take them out because I know I'm gonna replace them. This is simply inspection. Apply plate. You can see the difference in the color of this clutch pack. It's completely black. Completely black. Oh, look at that friction there. Oh yeah, babe. She's got some. So she's been cooking. So when I mentioned about the clutch pack in the 2.6, I believe it was a 2.6, you could see the steels had been overheated. You could see the hot spots, but the frictions were in better condition. So this clutch, these steels here, this is a friction. This one's being burnt, but you see on the back side of it, it's flat. There's no more ridges on it, so it's pretty much not gonna. It's gonna have a hard time creating friction, and it's gonna slip. So these are just look at them. These definitely gonna have to be replaced. I'm just going through them. This friction here has actually been worn down to the metal. You'll see the metals coming through. This is a friction. It's black. Can't really tell the color it's supposed to be, but you'll see the friction materials actually coming off of this one. You'll look at it and it's thinning out. That's going to give us tolerance issues, maybe some violent shifting. So this entire pack is going to have to be. There's nothing we can do with this. This is a 100% replacement. These are not reusable at all. The steels I'm talking about, especially not the frictions. Look at that one. So this is the failure, more than likely. This failure, is more than likely due to lack of lubrication, oil pump failure, converter failure, possibly. Maybe not so much converter failure. There was not that much metal, but this will cause no movement. So those are gonna have to be replaced. I'll just keep those there. You'll see how black the oil is in there. Definitely gonna have to replace. Get that drum refurbished. So this is the 1, 2, 3, 4, 3.5R assembly. These are a common fail point on these units 6L80. I'll show you, clean it up here. I'll show you what happened to them. This one, I thought it was kind of had some blowing. We check these drums, air pressurize them to check them. So what'll happen is around this seam here, the well will crack. So it will allow fluid to bleed out where it's not supposed to bleed out. That will cause obviously a non-apply situation. Low pressure, no applying. You won't shift, only one gear. It just won't work. So I'm gonna open it and see the condition of it again for the sake of knowing what's going on with it. The drum itself. Understand all of the rest of the drums are completely reusable. Even though this one's being charred, it's still reusable, cleaned off, reusable. Doesn't matter if the drum's been overheated. The integrity of it is more than likely not going to be changed. So it still can be reusable. But with these, because of that crack, we have to replace the drum. Or the possibility of that crack, because it's a known defect. General Motors is completely aware of it. We would just replace the whole entire drum. This is a loaded one here. It's brand new. You can get this drum loaded for like $300, $350, right? The whole thing ready to go. There's pistons inside. Everything's new, and you don't have to do anything to it. It's complete drop in. Versus, you can go to machine shops and get these welded. I have a lot of them just kind of laying around, loaded drums. But I just replace them. I don't even bother messing with them. I just replaced the whole thing. Just had another one. Oh, it's down there. There's another one there. So that one's gonna get replaced. Replaced. I'm sorry. Completely. Put that over there. But I'm gonna open it anyways just to see how the clutches and not the frictions, clutches, frictions, same thing. See how the frictions look, just to have an idea of what was going on in it. Snap ring around here. You'll notice with this drum, the snap ring has to go in one place. You can't put it. You have to put it where this shoulder does. This lug here doesn't have a shouldered area, so it has to go right there when you install it. Just an FYI, notable mention. Pull this out. Again, these snap rings are not that violent as the snap ring of death. There's two. Like again, this is 1, 2, 3, 4, 3, 5 in reverse. So 1, 2, 3, 4 is on the top. 3, 5 in reverse is on the bottom. This is the apply ring here. And you see, open these and see. These are actually kind of heating up too. You can see there, they've got some heat markings completely. Frictions aren't that bad. They're going to be, I mean, obviously we're going to replace it with a fully loaded new drum. This is an overhaul, so everything pretty much, all of the soft parts, paper and rubber, plastic, rubber, that's going to be, all those things are going to be replaced. Some heat on those. Frictions don't look that bad, but you know, we're pretty much going to have to replace this for the sake of the drum itself. 3.5R on the bottom side. I'm out of there. This is gonna have to play a little hardball with me, huh? Typically don't have problems with the 3.5R. It's usually the drum itself is usually the problem, which in turn will cause other issues that will prevent, you know, the operation of it. So, oh, these are tore up. Yeah, these are really tore up. Look at that one. Look at that. That is a friction. That's not a steel. That is a friction. But this is a friction. Steel. Friction. These are burnt up really good. Tore up. It's flattened out. This one's they're nearly going to metal, so not as bad as a 4, 5, 6, but they are bad. Got some material coming off here, it looks like. That's friction material there. A little kind of cardboard stuff. It's gonna get completely replaced. I could show you I mean, again, the pistons don't really matter. There's a applied piston down there. There's two of them right here. There's a balanced piston right here. There's a snap ring right here. Press it down. You press it down with the press, take the snap ring out, and they come out two little plates. You can apply air to it to get them out of there. If you have a air checking tool, which I do have, I'll just pop it in, pop them out of there. But there's really no point in me doing it because I have a loaded drum, a completely 100% loaded drum that this is going to be replaced. Like this whole thing is going to be replaced. So that's not really a necessity. That's not really necessary for me right now. This is going to go in the graveyard with the rest of them. I have plenty of them. Just in the event that I do have to repair a transmission, we have these parts. You know, these hard parts are still good. Frictions obviously are not. The steels come in handy if needed when doing repairs. But with overhauls, you know, if you get a complete overhaul, the majority of the soft parts have to be replaced anyways. So next we're going to take apart the valve body. I'm going to make a separate video for that to open it, and as well as the pump. And that way we can kind of break down what's going on with the pump. You know what? I can actually just take apart the pump and do the valve body separately. So that way we can have an idea of what's what went on with the pump, I don't need to make a separate video. The valve body can get a separate video. Let's just get the pump off. Pump and stator. This is the stator here. This is the pump housing. There's 2 sets of bolts, same size. They're all 7 millimeters. What was it, 8 millimeters? They're all 7 or 8 millimeters. Whatever. I think they're 7s. No, they're 8. The stator is separate from the. Is this an 11? Where's my 8? The stator is separate from the pump itself. Seems a 7. Told y'all. Nobody listens to me. But I'm gonna take it off and I'm gonna show you. Wow. What is going on? Let me see. I just put the 8 back, thinking it was a 7. Turns out it was an 8. Ain't that something? Oh no, I had an 11. That's what it was. What is going on, dude? So I'm missing. Oh, not. 1, 2, 3. Okay. I should be able to get it with this. I should need an extension. Having a hard time gripping these because my gloves. There's like 15 of these bolts. I don't remember. They're supposed to be tightened in a specific order. You don't necessarily have to loosen them in a specific order. 1, 2. That should be all of them. Again, I'm not going to take the stator off. I'm just going to take the pump off. Take these out. There's no Loctite on these. I always check to see if there's Loctite on them. Kind of give it a little wiggle and pull it straight up. This is the pump itself. This is the cover. We're going to take these vanes out. This is a 13 vane, I think it is. This is so pretty much what's going on. You can kind of actually see it right now. Once the torque converter feeds into these two little tabs here, it spins it. So these 2 tabs will correlate to the 2 tabs or the indentions on the torque converter. That way it spins it around. You'll see the fluids getting thrown around. Creates cavitation pressure. Not cavitation. It creates pressure, and it just throws it around through the entire fluid path. But I'm going to take this apart so you have an idea of what goes wrong with the pump itself. There's a kind of get this stuff. I'll use this as like a little base. So all these little veins are going to come out. So I'm going to try not to. Come on. Try not to let them fly everywhere. They're gonna fall. So this comes out here. Take it out and inspect it. I'm gonna create like a little fortress for the veins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 vein. I'm pretty sure I said that. Don't lose those. Gotta keep them. Next, we're gonna have to take this spring out. There is a Teflon seal here. Probably can't see it. There's a little Teflon seal in there. It's soft, so try not to damage it. I'm gonna take this out as well. There's a pin here that has to come out in order for it to lift up. First, we gotta get this spring out. Be very careful with this spring. It is very, very dangerous to try to remove. So what I'm gonna do is try to get it. I like to put my hands like that, just to kind of wiggle it up. You see how it's coming out, but I'm gonna kind of cuff my hand over it. Try not to scar the side of this, the pump. It's gonna get machined anyways, but it's gonna want to fly. I'm not. There it goes. It snapped. Kind of stung me a little bit. Just kind of pop. But be very careful when you prop against this. There's not much resistance when it's sliding forward, because again it's trying to push its way out. So you shouldn't have to get to a point where you're just like marring up the sides of it. But you don't want to create a leak there by just like really hanging on it. So now we can get this out. Sometimes you can wiggle it. What I'm doing is wiggling back and forward and applying upward movement on it. And you see it's kind of coming out. Just do it like that. Again, these two, this is a Teflon seal. This is important. Seal here. That matters. Don't lose that. This is just, well, the actual, so this is the seal. The black part's the seal. This yellowish piece is the actual, it's like a backing to make it more rigid. Kind of hold up against it, so to speak. We'll take this pin out. It has a spring on it. You'll see the spring there. It shouldn't come apart. No reason why it should come apart, so keep an eye on that. FYI, just in case, we'll take this gasket out of here. Everything doesn't want to move because it's kind of stuck to the oil. The oil is pretty much holding it in place. So I'm just trying to grab it. But that should be fine. So this gasket here goes on the back of the ring. It fits in like that. That's where that goes. You can keep it in there, but just make sure it doesn't have a. You want to make sure it's not torn or has a rip in it that can cause fluid to come through, that way a leak. I'll wipe the surface off. So this pump is definitely damaged. Well, the face is damaged, so this I can feel it in there. Can I feel it with my fingers? So it's scarred up pretty good. Poor lubrication, lack of lubrication. It shouldn't be scarred like that. It has to be machined and fixed for it to be repaired. We outsourced that to a shop. This is a necessity. It has to be done pretty much on all of these units. The pump is going to have to be machined as well, it looks like. Let me just do this. You'll see here it's got some scoring on the pump half as well. The pump itself, pump cover bell housing is not so much, but you'll see there it's pretty tore up. I'm going to take these boost valve, pressure relief valve, and check that next. The valves in this pump, typically what will go wrong is this boost valve, pressure relief valve right here, torque converter regulator valve. I haven't seen many problems with those, but I'll take. No, that's not gonna work. Just kind of give me. I just want to lay it here. That way I can take this valve out. Again, this bell housing is going to go to the machine shop, so all that's going to be repaired, but I just kind of laid it there just to make sure I'm not tearing it before I take this valve out. Boost valve is moving, so, but I'm going to take it out. There's a pin here that keeps it in, so what we have to do is get the pin out of there. Get a magnet. Push up against the boost valve. Pull the pin out. See how that works. I like to try to actuate it to make sure we don't lose that. Keep that together. But what I like to do is, you'll notice I was actuating it. when I'm doing that, when I'm actuating it like that, I'm trying to see if it's gonna hang up at all. So if this valve hangs, that's gonna cause a fluid flow issue. It's not hanging now. It's a good fluid movement. But if let's say for instance, if I was actuating it like I'm doing it manually, like here, and it goes down and I feel like it's hanging somewhere, that means okay, I got a problem. I have some metallic debris in there. The valve may have to be reamed out. Inspect the valve itself, not the valve. The bore will have to be repaired, reamed out. We replace the pressure regulator valves, regardless, because they're a known failure point on these pumps. There's a pin inside of this boost valve that pushes up against the piston. That pushes up against the spring that's in here, is about to come out next. But the boost valve itself looks in fair condition. Dama dozen stuff, just this is Dama dozen stuff, just replace it. But it looks in fair condition. Show you that piston again in case you didn't see it. But these are never really a problem. The pistons, the boost valves, sometimes depending on how bad the debris got into the pump, they will get damaged and got to replace them. So pressure regulator valve is coming out next. You'll see the double springs right there. The internal spring is the one that pushes up against that piston, and the boost valve rides on the larger one. So we'll try to get this pressure regulator valve out. So it doesn't want to come out, which is indicative of something. Not always. Sometimes it just get hung up. But we're going to see when we get it. We're going to see when we get it out of there, obviously. Check the lands on it. It is really in there, huh? I'm just trying to get it out of its bore. Get it to line up with its bore. This valve is going to be replaced, so valve is going to get replaced. The pump is going to get machined, so we're talking a complete refurbishing of it, so it doesn't really matter. But he acts like he doesn't want to come out. I'll grab it from one end, try to line it up and force it down. Finally got it out of there. What a time to be alive. Let's wipe it off, check out the lands on it. See how bad it is. Pressure regulator valve. This is a stock unit. This is a stock piece. It's not that bad. So these lands here are the sealing. These are the sealing elements, pretty much. If there was some scoring, kind of like this spot here, there's a little bit of it right there. That would be, indicative of wear, and there will be pressure loss, fluid loss. We have to replace it. The torque converter circuit this valve has to come out. We're going to check it. The other ones, mainly the stator, but this half here is pretty much where the problem is going to reside. So this is going to be a big issue. Just get this one out just to check it out. Kind of don't want to take it out though, because I know I'm going to have to reinstall it. Let me see if I can let me just see if I can actuate it, just to see, give you a visual idea of if it may be worn. So what I'll do is stick my pick down in there. You see it's moving. kind of actuate it all the way back to where as far as it'll go, just to see if it'll hang up. But it's not hanging up, and I'm not really seeing any damage on the lands as it's going back and forth. So more than likely not bad. Again, the machining process is going to have to be done on both the pump cover, bell housing, and the pump itself. So that's that. We're going to take the valve body apart next. Do that in a separate video. So y'all just stay tuned to the next one, and continue with this overhaul.